So now coming to MATLAB, so now I can show you some bits by bits, one by one, right? So if you go to C equal to 32, right? So like we'll go step by step, in the sense like I'll show you some few things, then I'll just directly input the code and run it. So if you put C equal to 32, so you can see, right, sorry, we have the C value of so 32, right? Now for MATLAB, in order to clear any values, so you have the CLC, right? Then if you type, right, so it will, right, so CLC will clear this command window basically, right, for the MATLAB. Okay, now coming to, if we give the value same as that we have given in the program, C equal to 1:32, if you enter it, so you can see now that it had made 32 columns, right? Now it has 32 columns, right? Now if I put D equal to 2, so it has a value D or parameter D with value 2, right? Now if I take dx equal to 1, so, and dt equal to 0.1, right? So now it has taken all the values, right? Now if I come to my program, right, and right, so now that it is clear to you that we have taken 32 intervals, right? 32, basically we have taken this, we have divided this whole thing into 32 as I mentioned, right? And for this also, right, this whole thing into 32, and for this also you can see that we have d equal to dt equal to 0.1 and dx equal to 1, the length derivative, right? Okay, so now coming to MATLAB, and if I take this command and copy and paste it over here, so you can, and if I put enter, so you can see that it creates a separate window, which is the figure window. So if I put it over here, right, so let me put it to this side, slightly to this side, right? So this will have, right, this is, so this is what we have now, right? Right, so now we have created this figure, right? So coming to the command window, so for k 0 to 1000 we have this equation to be followed, right? So if I copy, if I paste it, right, and if I put enter, so you can see nothing is there, right? Still nothing has happened, still right now nothing has happened. Okay, now if we come here, now if we take if mode k grid on, right, so if we take this command, right, and if we copy it, so first of all, if we take this much command, right, if we take this command and if we paste it, enter, still nothing has happened, right? So when up to this point, when we have copied and pasted, so nothing has happened. Now what we are going to do is, now we will take the rest and copy and paste it. We will copy this one, this part of the code, and we will paste it over here. So now you can see automatically. So see, up to this point, up to the point of the equation, we were just giving the equation, the parameters. Now after this, everything is about plotting the graph, right? The whole code is about plotting the graph, right? So here we have t equal to 0, t equal to 10. So now you can see this is the graph over here. Now if I expand it, so you can see over here that for t equal to 0 seconds, we have the concentration. Then for t equal to 10, t equal to 20, t equal to 30, 40, 50, 60, right? So up to 100 seconds. So if you remember, if we come to the plot once again, right? So if we come to the code once again, so we had taken if mod is k, right, and 100, right? So we don't have to plot anything, right, but subplot. So for 11 subplots, so we have to create 11 subplots. So you can see over here, if you count, there are 11 subplots, right? T equal to 0, 1, 10, 20, 30. So total 11 subplots are there, right? And 11 subplots are there for k 100 plus 1, right? So that means for after every 100th k, so basically starting at t equal to 0, right? Starting at t equal to 0, then after k 100, right, 100 plus 1, so at k 101, so the time difference dt is 0.1, 0.1 into 100 being 10, so at t equal to 10 seconds, right? So the difference of for the plot is 10 seconds, right? So similarly at the 11th plot, we have the 100-second difference, right? Total cumulative time is 100 seconds, right? And accordingly the diffusion is there. So you can see the diffusion is like the particles have diffused, okay, right? So you can see the equation working over here about the diffusion. So this equation works perfectly for the diffusion or for the generic diffusion, right? So this is what we wanted to program and simulate and verify the equation, okay, and this is there, right? So that's it for this. From the next session we'll start with the basic understanding of the thermodynamics also with this, right? And then we'll move on to the further topics.